All right, let's look at the homework 4.4, problem number 1. All right, so we want to find the correct picture for this function given here. All right, so you can see that it's just starting out with the natural log function, and you're going to apply a reflection about the x-axis, and then this is going to shift to the right 4 units. All right, so let's do that. All right, so I'm going to use GeoGebra to demonstrate this. All right, so if you forgot what the natural log looks like, so we can look at the corresponding exponential function. For example, y equals e to the x. All right, so we know that the y to the e to the x looks like this. Right? And then since the natural log of x is the inverse of this exponential function, the graph is going to be symmetric about the y equals x. So I'm going to draw y equals x there, right? And I'm going to actually make it look a little bit different. I'm going to do a dotted line, right? So we have that. All right, so the natural log function is going to be a reflected version about this line. So let's do a reflection. All right, so I can do this reflect about a line. So I take this graph, right, and reflect it about this line here. All right, so this is going to be the graph of the natural log function. All right. Then what we need to do is we need to reflect about the x-axis. Let's see here. All right, so we got the natural log function, but this -1 is a reflection about the x-axis. So let's apply that. So I'm going to reflect again. So reflect this guy about the x-axis. All right. So this is the graph of negative natural log of x. All right. And after that, we just need to shift it to the right 4 units. So let's do that. To do that, I need to create a vector, right? So it's a vector here, right? So it just tells you which way and how much it goes. So it's going to go from, say, 0, 0 to 4, 0. So it's a direction to the right 4 units, right? So I'm going to I'm going to translate it. So take this resulting vector, the graph here, and shift it to the right 4 units. So this is the picture here. All right. So I'm going to maybe change. I'm going to maybe let's see. I'm going to maybe erase all the intermediate ones. That's just a point. Actually, we don't need these. All right. So this is the picture right here. All right. Let's see if it's the correct one. So you have y equals negative. Actually, let's do a picture here. Here. So this is supposed to be the natural log of x. Let's sketch the y equals natural log of x. All right, so you can see that that fits exactly where we thought it's going to go. All right, and the next one is a reflection. So if you apply a reflection, so y equals negative natural log of x, and you're going to end up exactly there. All right. Then after that, we're gonna do a shift. So it's going to be y equals negative natural log of x minus 4. So this is going to shift the result, shift this picture to the right 4 units, hopefully, right? And hit enter, right? So you can see that it fits exactly there, right? So the graph is going to be a reflection about the x-axis and shifted to the right 4 units, right? Which one is that? Oh, that's not the right one. Here. All right, so here, looks like it's only shifted 3 units, so this is not going to be it. All right, this one is shifted 4 units, but there's no reflection, so this is not going to be it. All right, so this is 4 units and shifted, and then there's a reflection applied. It's probably that this is the right one. All right, let's see if, right, this one shifted only 3 units to the right. So we know that the correct picture would be this one. All right, let's check the answer. All right, I came back and it looks like we got the picture correctly. Correct picture is this one right here. All right, that's it. I hope that this was clear.